Welcome back to this explainer on functions. Today, we're going to learn exactly how to package your logic into reusable blocks, because honestly, you should absolutely never be doing the exact same work twice. As developers, our time and cognitive energy are our most valuable assets, right? And functions are literally the ultimate tool for protecting both of them. Let's dive right in. So to kick things off, let's think about a critical question regarding efficiency. Why do professional software engineers completely avoid repeating themselves? Well, it's not just about being lazy, though, hey, strategic laziness is definitely a virtue in programming. It's actually about maintaining really clean systems. When you write the exact same code in multiple places, you're just creating multiple points of failure. If a bug pops up, you have to hunt it down and fix it everywhere. Experts, yeah, they avoid that completely. And that brilliantly illustrates our very first core concept, the dry principle, or don't repeat yourself. This is a foundational software rule. Instead of doing the manual labor over and over again, we need to think like architects. We build these tiny specialized machines to do the heavy lifting for us exactly when we need it. To keep things organized, here is our mental roadmap for the next few minutes. We're going to cover 1. The problem, 2. The analogy, 3. The syntax, 4. The application, and finally, 5. The error. All right, section 1. The problem, the hook. Okay, imagine your program is just this tangled, messy knot of logic. If you're staring at 3 separate loops all trying to print different user lists, you can instantly feel the frustration, right? It's what we notoriously call spaghetti code. If you suddenly need to change the format, you have to untangle everything and manually update that logic in 3 different places. No thank you. So mastering how to properly package this logic is absolutely essential as we look at the evolution of software engineering, especially heading into the incredibly complex agentic AI systems dominating the landscape in 2026. Writing repetitive code simply is not going to scale. We absolutely need clean, reusable blocks to interface with these advanced AI models. Moving on to section 2, the analogy, the coffee machine. Since programming concepts can feel a bit abstract sometimes, think about a standard coffee machine. You don't build a brand new heater and grinder every single time you want to drink, right? Of course not. You just press a button. In our analogy here, the beans you put in are your parameters, or your input. The machine itself, the part doing the grinding and brewing, is the function body where your instructions live. And that hot cup of coffee you get at the end, that is your return value, your output. A function is really just a pre-built machine hiding complex instructions behind one simple name. Section 3, the syntax, breaking down the machine. Now, to avoid overwhelming your brain, every single function is composed of 4 critical pieces that we're going to deconstruct one by one: the return type, the name, the parameters, and the body. Our first piece is the return type. This simply dictates what the machine is actually giving back to us. Does it hand back an integer, like an int, or does it give us absolutely nothing back, in which case we use the keyword void? It basically just sets the expectation for the output. Next up is the name. This hides all those complex line-by-line instructions behind a super simple readable label that we use to call our machine into action. Using something descriptive like print greeting tells us exactly what this specific machine does just by glancing at it. The third piece is the parameters. Remember our coffee beans? This acts as the necessary input that the machine absolutely needs to operate properly. If our machine prints a personalized greeting, well, it needs to know who it's greeting, right? So we pass it a string name. And finally, we have the body. This houses the actual step-by-step instructions, all neatly tucked inside curly braces. Whenever you call the function by its name, your program runs exactly what is inside this body. All right, section 4. The application. Live coding your first machine. We are going to define our brand new greeting machine at the very top of our file, right above our main loop. And there is a very specific logical reason for structuring our code exactly this way. As the rule goes, we define the machine here so the program knows it exists before we use it. You see, C++ reads your files from top to bottom, so defining it early guarantees the compiler actually knows our machine exists before we ever try to call it into action later on. When you actually write this personalized welcome message out, putting together your void return type, your string parameter, and your body logic, readability is absolutely key. We highly recommend a high-contrast, distraction-free setup, because honestly, about a third of you are watching this on smartphones. Organizing your screen cleanly ensures zero cognitive friction when you're reading through your logic. Which brings us to section 5, the error, growth mindset, and missing returns. Now, consider a scenario where you get a glaring red compiler error. Our function promised to return an int, a number, but we completely forgot to include the return statement inside the body. Listen, everyone, literally even the absolute experts, makes this mistake sometimes. Understanding why a machine fails to deliver on its promise is a totally normal, expected part of your learning journey. So why does pushing through that error actually matter? Because developing the muscle to independently debug and fix these exact compiler errors is precisely what unlocks those really lucrative software engineering roles. In the 2026 market, strong foundational problem-solving skills combined with modern tools are commanding starting salaries of 10 to 15 lakhs per annum. Overcoming these hurdles is literally how you build your career value. To wrap up this explainer, I really want you to look beyond your code editor. The DRY principle, don't repeat yourself, isn't just for software. It's an entire mindset for efficiency. So I'm going to leave you with this final thought. What other repetitive, mundane tasks in your everyday life could you build a machine, a system, or a function for today? Think about it. Thanks for learning with me, and I'll catch you in the next explainer.